Hi guys, welcome back again to my channel. So here is the last part of the exercise on relation. So in this session, the very first question is question number 12. I am skipping the questions 10 and 11 because from the question number 7 up to question number 11, these are all similar. So let's not get bored. So let's proceed from question number 12. Prove that the intersection of two equivalence relations in a set is an equivalence relation again. We have to prove that if there are two equivalence relations, then intersection of that relations will be again an equivalence relation. And also give an example to show that the union of two equivalence relations is not necessarily an equivalence relation, but the union of two equivalence relations need not to be an equivalence relation. So here the solution is, first of all, let us consider two equivalence relations. Let us consider two equivalent relations A and B on this set. Suppose this is L. We have considered two equivalence relations on this set L. Now here A is subset of L cross L because L is the relation on this set L. Similarly, B is also subset of L cross L. If A is subset of L cross L and B is subset of L cross L, that means A intersection B is subset of L cross L. Now, A intersection B is a relation on the set L. Now, we have to prove that this relation is an equivalence relation. So first of all, we have to check whether this is reflexive. Now, let's proceed. Let us take an element small a belongs to the set L. Then ordered pair A comma A will be belonging to the set A, and similarly that element also belongs to B, because we have already assumed that A is an equivalence relation. Since this is an equivalence relation, so this is obviously reflexive, so this element belonging to this set A. Similarly, B is also an equivalence relation, therefore this element belongs to B because B is reflexive. So when a single element is containing in two different sets A and B, that means in the intersection of those sets contain the element AA. Therefore, ordered pair A comma A belongs to A intersection B. If an element in this form belonging to this relation, that means this relation is reflexive. For symmetricity, let us take two elements small a and small b belongs to set L, such that the ordered pair A comma B and such that ordered pair A comma B belongs to A intersection B. So we have taken an element ordered pair A comma B belongs to A intersection B. Now A intersection B means in A the element AB is contained. Similarly, AB is also containing in B. Therefore, I have written this AB belongs to A and AB belongs to B. Now, since we know that A is an equivalence relation, so if an element exists in A, then the element BA also belongs to A. That means A is reflexive. It is already given. Similarly, for an element AB belonging to B, we get BA also belongs to B because B is reflexive. Now, combining these two, BA belongs to A and BA belongs to B, we get BA belongs to A intersection B. BA belongs to A intersection B. So whenever we take an element AB belongs to A intersection B, we finally get ordered pair B comma A belongs to A intersection B. Therefore, the relation A intersection B is also symmetric. Now the transitive part. Let us take three elements A, B, C belongs to the set L such that ordered pair A, B belongs to a relation A intersection B and other element B, C belongs to A intersection B. Here we have taken two elements A, B and B, C in A intersection B because we have to prove that this relation is also transitive. So to show transitivity, we have to make sure that there exists an element AC. There exists an element AC also belongs to A intersection B. So for that, AB belongs to A and AB belongs to B. I have written this from this line. AB belongs to A and AB belongs to B. Similarly, BC belongs to A and BC belongs to B. Now we have AB belongs to A and AB belongs to B. So we combine the elements in A and in B separately. Now AB, BC belongs to the set A and AB and BC belongs to B. Now since A is an equivalence relation, therefore A is transitive. And if A is transitive, then for two elements like this, AB and BC belongs to A, then we get AC belongs to A. So finally I write AC belongs to A. In the similar way, since B is an equivalence relation, therefore B is transitive. Therefore, for two elements like AB and BC belonging to B, we get AC belongs to B. Now, the element AC is common. So, AC belongs to the intersection of these two sets. Therefore, AC belongs to A intersection B. That means, for two elements AB and BC belongs to A intersection B, we get the third element AC belongs to A intersection B. Therefore, this relation is transitive also. Since the relation A intersection B is reflexive, symmetric, and transitive, hence this relation is an equivalence relation. So, the first part is done. The second question was so with an example that it is not necessarily true to get an equivalence relation whether two relations are given as equivalence relations. So we have taken a set. A equal to A, B, C. Now let us consider two relations P and Q which are equivalents defined on the set A. P and Q are two equivalence relations defined on the set A such that P contains the element AA, BB, CC, AB and BA. And relation Q equal to AA, BB, CC, BC and CB. Now we have to check either the union of P and Q. Either P union Q is an equivalence relation or not whenever we are given that P and Q are equivalents, because for equivalence P should be reflexive, symmetric and transitive. Here the elements in the form AA, BB and CC are here. So P is reflexive. For symmetry, for the element AB we have BA, so this is symmetric also. And for transitivity, for the two elements AB and BA, we get the element AA, which is this. So this is reflexive, symmetric and transitive. Similarly, Q is also an equivalence relation. You can check it here. Now, if we take P union Q, then we will get the elements. Sorry, this is AA, BB, CC, AB, BA, BC and CB. the union of these two set contains the element this. Here P union Q is not transitive. How? Because for the element AB and BA, for the elements AB and BC, we have to uh, find the other element AC. For the element AB and BC, the other element should be AC containing in this set. But there is no AC in P union Q. That means this relation P union Q is not transitive. If this is not transitive, then obviously P union Q could not be an equivalence relation. So this second part is also done. So you can see here from here to here the second part. Now question number 14. If R equal ordered pair 1, 2, 2, 3 is a relation in the set of natural number and list the least number of ordered pairs to be induced in R so that R is an equivalence relation. So answer is here R is given as ordered pair 1, 2 and 2, 3. We have to make R as an equivalence relation. So what should be the elements to be induced in R so that R will be an equivalence? So here it is very obvious. So the least number of ordered pairs to be induced in SIR in such a way that R is an equivalence relation. So these are 1, 1, 2, 2, 3, 3, 2, 1, 3, 2, 1, 3 and 3, 1. Because for the element 1, 2, we should obtain the element 2, 1, which I have written below, so that the relation R will be symmetric. Similarly, for the element 2, 3, we have to obtain 3, 2, because R have to be symmetric. Similarly, 1, 3 and 3, 1 will be the elements to be induced in R. And also for reflexive, we have to induce the elements 1, 1, 2, 2 and 3, 3 in R, so as R is a reflexive relation. So the total number of elements to be induced in R will be 1, 1, 2, 2, 3, 3, 2, 1, 3, 2, 1, 3 and 3, 1. If we induce these elements in R, then only we can say R is an equivalence relation. So this is done. So have you noticed I am skipping question number 13. I have done this question number 12 and 14. I am skipping question number 13 because this is very similar to number 12. And also you can do the problems question number 10 and 11 yourself from the book A Class Book of Mathematics. Here it is, A Class Book of Mathematics for class 12 by Esan, based on NCERT syllabus. So this is the book, you can use it. This is very helpful, and question number 12 is very important for you, so do watch the video properly. So if you have any query about question number 10, 11 and 13, then you can ask me in the comment section, then I can surely help you. So this was the session today. I hope you are all enjoying. So if you think my videos are helpful to you, then subscribe to my channel and also share it with your friends. Until then, bye bye. Thank you.